Hello and welcome to another Algebra 1 video. Today we'll be starting chapter 2, which is writing and graphing linear equations. We'll first begin with lesson 2.1, which is graphing linear equations. Let's first look at a definition of a linear equation. So a linear equation is an equation whose graph is a line. The points on the line are the solutions of the equation. So let's take, for example, in this image, we have the linear equation y equals 1/2 x plus 2. That equation is represented by this red line drawn here. And any point on this line, such as this one, or even this one, would be considered solutions of the equation. So for today, we'll be covering how to graph these linear equations using a table of values. Let's first look at this example. We have the equation y equals 2x plus 1. The first thing you want to do is make a t-chart for your x and y values. Now first notice how your equation is structured. It's always set to an isolated y value. So what you can do is plug in any number you'd like, preferably smaller numbers, into your x value and get your y value. So let's go ahead and take a look at how this works. Let's say, for example, you plug in 0 for your x value. If you were to plug in 0 for your x, you would get 2 times 0 plus 1 equals to y, which would just be 1. And now that you've done that, you can see here that you have a pair of coordinates that you can plot for your line. The minimum number of points that you'll need for a linear equation is 2, but if you want to be more precise, you can do more. I'll just go ahead and do 3 for this example. So once again, you can plug in any number you'd like for your x value to get a y value. Once again, it would preferably be smaller numbers so that it's easier to calculate. So I'll go ahead and do 1 for our next value. So if I plug in 1 for my x, I get 2 times 1 plus 1 equals to y, and that would just equal to 3. Then I could also do negative numbers if I'd like -2. Plug in -2 for your x, you get 2 times -2 is -4 plus 1, and that would be -3. Now you see here that you have a collection of coordinates that you can now plot to create your line. So I'll first plot 0, 1, and then I'll plot 1, 3, and then -2, -3. Now that you have all your ordered pairs plotted, you can go ahead and draw a line through the points. And that's how your line is going to look like. Let's look at another example here. We have y equals 3x minus 2. We're going to first begin with plotting our points. So go ahead and plug in 3 different values for x. I'll do 0 once again. So 3 times 0 minus 2 would just be -2. You can also do 1. So 3 times 1 would be 3, minus 2 would be 1. And then I'll go ahead and do -1. So 3 times -1 would just be -3 minus 2, and that would equal to -5. So that would be your last ordered pair. Now you can go ahead and plot them. So I'll go ahead and first plot 0, -2, then 1, 1, and then -1, -5. Now that you have all your ordered pairs plotted, go ahead and draw a line through them. And that's how your graph is going to look like. Okay, let's go ahead and look at this example. We have -2x plus y equals 5. Now notice here, there's a big difference in the way our equation is structured. Recall that all our previous examples have y isolated and set to the equation. In this case, it's set to the constant 5. Now, before you graph, you actually have to rearrange this equation using inverse operations to isolate y and make the equation set to y. So that's pretty simple to do. You would just use inverse operations, in this case, adding 2x to both sides. 2x cancels, and you get that y equals to 5 plus 2x. So a reminder, whenever you're trying to graph an equation like this, using a table of values, always first solve for y when you're given an equation. So our new equation would be y equals 2x plus 5. And we can now plug in our x values now that our equation is set for y. So I'll go ahead and first plug in 0. 2 times 0 would just be 0, plus 5 would equal to 5. I'll plug in 1 next. So 2 times 1 would be 2, plus 5 equals to 7. And then I'll plug in -1. 2 times -1 would just be -2, plus 5 equals to 3. And now that I have all my ordered pairs, I'll go ahead and plot them on my graph. So first 0, 5, 1, 7, and then -1, -3. Now that I have all those plotted, we can go ahead and do our last step, which is draw a line through the points. And that's how your graph will look like. Let's look at another situation you might encounter when graphing linear equations, in this case, graphing horizontal and vertical lines. So the graph of y equals b represents a horizontal line that passes through the point 0b. So really, whenever you see an equation set to y and equaling a constant, you would know that it is a horizontal line. So for example, if you have y equals 4 on your coordinate plane, you would first find 4 on the y-axis and then draw a horizontal line through that point. And that's how your graph would look like. As for vertical lines, the graph of x equals a is a vertical line passing through a equals 0. So take, for example, you have x equals to -3. Go ahead and look at your coordinate plane and locate -3 on your x-axis. Once you found that, you can go ahead and draw a line through that point, which would just look like this. And that is how your vertical line would be graphed. Let's go ahead and take a look at another example. We have 5x plus 7y equals 21. Now notice that our equation is not set to y. So let's go ahead and first solve our equation for y. I'm going to go ahead and use inverse operations again. First, undo any addition or subtraction of additional terms. In this case, 5x. So just subtract 5x from both sides, and you're left with 7y equals to -5x plus 21. Now to isolate y, I'm going to go ahead and divide both sides by 7. 7 cancels, and now your equation is solved for y. It will be y equals -5/7 x plus 3. And now you can go ahead and plug in your x values. Now notice here that you're working with a fraction, so try and target values that will be able to get rid of that fraction. For example, 0 would just make -5/7 times 0, 0, plus 3 would be 3. And then I'll go ahead and try and cancel out the denominator here by multiplying by 7. So I'll plug in 7 for my x value. I do 7 over 1, and 7 will cancel. You're left with -5 plus 3, and that would just equal to -2. And then I'll go ahead and also do -7. If I multiply both sides by, if I multiply -5/7 by -7, so you would be left with +5 plus 3, since the negative and -7 will cancel out the negative, and then 5 plus 3 would just equal to 8. So that will be your third ordered pair. Now that you have all 3 of your ordered pairs, go ahead and plot them. So first 0, 3, then 7, -2, and then -7, 8. And now you can go ahead and draw your line through your points, and that's how your graph will look like. let's do one last example. We have x plus y equals 2. Our equation is not solved for y, so let's first solve our equation for y. In this case, we just have to subtract both sides by x, and you get y equals to negative x plus 2. Now, since you do have a negative, you're going to have to multiply your x values by the negative. So for example, if you have 0, 0 wouldn't be affected, so it would just be 0 plus 2 would be 2. However, if you have positive 1, you would have to put 1 in parentheses and multiply it by your negative, and that would just give you negative 1 plus 2. And then so your y value would be 1. In the case of a negative number like negative 1, you would have to once again put it in parentheses and multiply it by the negative. So that would just give you 1 plus 2, and that would give you 3. Now that you have all your ordered pairs, you can go ahead and plot them on your graph. So here is 0, 2, 1, 1, and then negative 1, 3. And go ahead and draw your line through your points, and there is your graph. We'll go ahead and be moving on to lesson 2.2, which is slope. So let's go ahead and first define what slope is. So the slope is the steepness of a line. There are going to be 4 kinds of slope that you'll encounter. First, positive. And if you look at it on a graph, you'll see that it is going up towards the right or the positive side. You'll also have a negative slope, which if you look is going up to the left side, or I like to think of it as the negative side since you have all your negative values right here. You'll also have a 0 slope, which if you recall, the horizontal lines that we went over in the previous lessons, your slope of a horizontal line would be 0. And then an undefined slope, which would be the slope of a vertical line. So always remember your 0 slope is for horizontal lines, undefined slope is for vertical lines, negative slope will go up to the left, and positive slope will go up to the right. To find the slope from a graph, you're going to first start with the point furthest to the left. Then you're going to count the vertical change, which is the rise or fall if it's negative, and then count the horizontal change, which is the run. You're going to write your answer as a simplified fraction. So this is the format you're going to write your answer in, rise over run. So let's say, for example, we have this line and they're asking us to find the slope. You can start from any solid point furthest to the left. So I'll just go ahead and go with this point, and I'm going to go ahead and count the vertical change until I can find another solid point. So in this case, this one. So go ahead and first plot 2 different solid points, and then that'll make it a lot easier for you to find the horizontal and vertical difference. So I'll go ahead and start from this point right here and count the vertical change. So that's 2 units up. And then I'll go ahead and count the horizontal change right here to the other point, and then that would be 3. So your slope will equal to rise over run, or 2 over 3. And remember to present it as a simplified fraction. In this case, you can't simplify 2/3 to anything else, so that would be your slope. Okay, for our next example, we have graphed a line containing the points -4, 2, and 2, -3, and find the slope. So let's go ahead and first graph our points, -4, 2, and 2, -3, and then draw our line through them. We can see here that we don't have to identify our points this time since we've already been given the points. So we can go ahead and start from our leftmost point, which is -4, 2. And notice now that our graph is actually pointing up to the left and pointing down to the right. So that indicates that in this case, we have a negative slope. So we'll be counting down. So from -4, 2, let's count down to 2, -3. So our vertical change or our rise, in this case downward, would be 1, 2, 3, 4, 5 units down. And that would be our rise. And this will actually be expressed as -5 since we have a negative slope. And then our horizontal change is 1, 2, 3, 4, 5, 6 units. So our run would be 6. And that would be your slope, -5, 6. Okay, let's look at another example. So we're going to graph the line containing the points 1, 1 and -2, -3, then find the slope. So go ahead and first plot your points 1, 1 right here, and then -2, -3. Then you can go ahead and draw your line. In this case, really convenient that we already have our points identified. So notice here that it is actually pointing up to the right. So we know that this is a positive slope. So start from your leftmost point and count up your vertical change until you hit where your other point is located. So that would be how many units up? That'd be 1, 2, 3, 4 units up. So your rise would be 4. And then your horizontal change until you finally hit -2, -3 is 1, 2, 3 units. So your slope, which is represented by the variable m, will equal to 4/3. Okay, you can go ahead and pause the video and try these examples on your own. If you're not feeling too confident, no worries, we'll go ahead and go over them right now. So for this first example, we can see that our leftmost point is located right here. So I'll go ahead and first count the vertical change. Notice here how it's going up to the left, so we know that it's negative. So we're going to be counting downward for our vertical change. That would be 1, 2, 3, 4, 5, 6 units down. So -6 over 1, 2, 3 horizontal units. So remember, we express it as rise over run, and that would equal to -6, 3. However, recall that you want to express it as a simplified fraction, so that would be -2. So your slope, which is represented by the variable m, will equal to -2. For this one, on the bottom of our first example, we can see here that it is pointing upwards to the left, so we know that it is negative. So we can see here that our leftmost point is right here. And then we have our other point that we're counting down to. So our vertical change will go downward 2 units until we hit where our other point is. And then count your horizontal change until you hit your point, which is 1, 2, 3. So your horizontal change would be 3. Rise over run. Your rise going downward is -2, and then your horizontal change would be 3. Let's go ahead and look at this example. We see that it's pointing upward to the right, so we know that it's positive. Go ahead and start with your leftmost point and count your vertical change, 1, 2. And now that you're level with your other point, you can go ahead and count your horizontal change, which would be 1, 2, 3, 4, 5 units. So your slope would be m equals to rise over run, which is 2/5. Let's go ahead and look at our last example. Once again, first identify whether it's negative or positive. I can see here that it's pointing up to the right. So start with your leftmost point and count your vertical change until you're level with your other point. So that would be 2 units up over 1, 2, 3, 4, 5, 6 units. So that would be 2/6. And recall that you have to present it as a simplified fraction. So that would just be 1/3 if you simplify by a factor of 2. Okay, so here are all the answers typed out. Let's go ahead and move on. So what is the slope of this line? We have 2 points, -6/4 and 5/4. Now this is actually a trick question because if you recall from the very first slide of this lesson, we know that our horizontal lines have a slope of 0. So the slope of this line would just be 0 slope. Nothing to calculate here. And what is the slope of this line? You have a vertical line with the points 3, 8 and 3, -2. Again, there is no counting of the slope that you have to do. Just always know that whenever you see a vertical line, your slope will be undefined or no slope. Okay, let's go ahead and look at our slope equation, which is another method of finding your slope given 2 points. So you have slope, or m, equals to y2 minus y1 over x2 minus x1. So find the slope of the line that contains the point 1, 1, and 3, 5. Now this y2 and y1 are just indicating which ordered pair it is. So when you're looking at 1, 1 and 3, 5, you want to assign them values. So for example, this can be ordered pair 1, so that will represent y1 and x1 and y1, and this can be ordered pair 2 or x2 and y2. It does not matter which ordered pair you want to label as 1 and 2, just make sure that you're plugging them in correctly. So if you have y2 minus y1 and x2 minus x1, I'll go ahead and assign this x1 and y1, and then this one as x2 and y2, as I did previously, and then get your slope equation out. So you have y2 minus y1, your y2 is going to be 5, so plug that in first, and then your y1 value will be 1. So your top half of your slope equation will be 5 minus 1. Then move on to your x values. You have x2, which is 3, minus x1, which is 1. And now that you have your equation set up, you can go ahead and work this out. So 5 minus 1 is 4, and 3 minus 1 is 2. And that can actually reduce to just 2. And that is your slope. Let's go ahead and look at another example. We have find the slope of the line that contains the points 2, 2, and 8, 9. So once again, I'm just going to first assign which ordered pair is 1 and which ordered pair is 2. Again, it doesn't matter. Just make sure you're plugging them in correctly. So 2, 2, I'll assign x1 and y1, and then 8, 9, I'll assign x2 and y2. So I'll go ahead and now plug this in. y2 is 9 minus 2, and then x2 minus x1 would be 8 minus 2. Now I'll go ahead and work this out, and I get 7, 6. 7, 6 can't reduce into anything further, so that will be my slope. Okay, another example. Find the slope of the line that contains the points -4, -6, and 3, -2. I'll assign -4, -6 as my first coordinate, so x1, y1, and then 3, -2 as my second ordered pair, so x2, y2. Go ahead and plug it in, and make sure that you're accounting for the negative in front of your values. The equation is set up as y2 minus y1. So make sure you're putting your negatives in parentheses so that you do not confuse yourself when you're working this out. So your -2 minus -6 would cancel, and that would give you -2 plus 6, and that would give you 4. And as for the bottom, you have 3 minus -4. The negatives will cancel, and you'll just get 3 plus 4, and that'll give you 7. So your slope would be 4/7, and it can't reduce into anything further. So that is your slope. Okay, you can go ahead and pause the video and try this out on your own. If you're not feeling too confident, no worries. We'll go ahead and go over it right now. So we have the points -2, 3, and 2, 1. I'll go ahead and assign them as ordered pair 1 and 2. So -2, 3 will be 1, and then 2, 1 will be ordered pair 2. And now I'll take out my equation, which is y² minus y1 and x² minus x1. Remember to always account for your negatives so that you get the correct answer. So y2 minus y1 will be 1 minus 3, and then x2 minus x1 will be 2 minus -2. The negative cancels, you get 2 plus 2. 1 minus 3 will be -2, and 2 plus 2 will be 4. So you get -2/4 for your slope. That can be reduced by a factor of 2, and you'll get -1/2. That will be your slope. Okay, let's go ahead and look at another situation where we're given a table of values for our ordered pairs. So the points in this table lie on a line. How can you find the slope of the line from the table, and what is the slope? So let's go ahead and apply what we've learned just right now to find the slope given a table of values. You can actually find the slope through the slope equation, which is stated right here. You can pick any 2 points within this or ordered pairs within this table and then plug them into your slope equation. So for example, I'm just going to go ahead and take the 2 points 1, 2, and 3, 5, but you can really take any 2 ordered pairs you'd like. And then I'll go ahead and apply the slope equation. I'll assign 1, 2 as my first ordered pair, and then 3, 5 as my second ordered pair. And now I'll go ahead and plug those values into my equation. So 5 minus 2 for y2 minus 1 over x2 minus x1, which would be 3 minus 1. And that'll give me my slope, which is 3/2. And 3/2 can't be reduced into anything further. So that's your slope. We're going to go ahead and finish off today with lesson 2.3, which is slope-intercept form. So what slope-intercept form is it's another method of graphing linear equations, except unlike our first method that we learned in 2.1, which was just making a table of values, slope-intercept form is a lot less time consuming and has less room for error, since of course you can always make an error when you're calculating your y value. But let's go ahead and first look at what slope-intercept is. So this is the slope-intercept equation, and this is how you always want your equation to look like whenever you're trying to graph using slope-intercept form. So it is y equals mx plus b, with m representing your slope and then b representing your y-intercept. So recall from 2.2, slope is the steepness of the line, and then your y-intercept is where your line is going to intersect with the y-axis. So the y-intercept is represented by this yellow point right here. So take, for example, this line. Your y-intercept is just going to be where your line intersects with your y-axis, which in this case is at 2. Okay, let's go ahead and find the slope and y-intercept of an equation. So you're going to first solve your equation for y. So always make sure your equation is set to y. It's going to look like this. Y equals mx plus b. M, once again, equals the slope. And b is the y-intercept, or where the line will cross the y-axis. So let's find the slope and y-intercept of y equals -5x plus 6. Now always keep in mind your format y equals mx plus b. Your slope m will be this coefficient of x, which would be -5. So m will equal to -5. And then your y-intercept will be this b value right here, which is the constant. So b will equal to 6. So identifying your slope and y-intercept should be pretty simple. Slope will equal to -5 and intercept will equal to 6. Okay, let's go ahead and find the slope and y-intercept of 2y equals 7x minus 4. Now we have to first solve for y, since we can see here that it's being multiplied by 2 and isn't completely isolated. So solve your equation for y by dividing both sides by 2. 2 cancels out. And then you're left with y equals to 7/2 x minus 2. Now that you have your equation solved for y, pretty simple to find the slope. Y equals mx plus b, 7/2 is x, or m, sorry, and then -2 would be your y-intercept, or b. Always make sure to consider what sign is in front of both your slope and your y-intercept, since that is really crucial in stating the correct y-intercept and slope. So your slope would be 7/2, and your y-intercept, or b, equals to -2. Okay, here's another one. We have find the slope and y-intercept of 2x plus 3y equals 6. Of course, we want to first solve for y. So I'm going to first undo any addition or subtraction of additional terms, in this case 2x. So subtract 2x from both sides and 2x cancels. You're left with 3y equals to -2x plus 6. Of course, you can also put 6 minus 2x, but I'm trying to rearrange it to fulfill y equals mx plus b form, so that it's more simpler to identify my slope and y-intercept. So now you can isolate y by dividing both sides by 3. 3 will cancel out on the left side, and you're left with -2/3 plus 6/3, which would be 2. And now that your equation is solved for y, go ahead and identify your slope and y-intercept. Slope, or m, is right here, the coefficient of x, which would be -2/3. And then your y-intercept, represented by b, would be 2. Let's go ahead and look at this example. We have -7x minus 5y equals to 25. Once again, we're going to first solve for y. So first undo any subtraction or addition. In this case, the subtraction of 7x. So I'll go ahead and add 7x to both sides. 7 cancels, and then you're left with -5y equals to 7x plus 25. And now you can go ahead and divide both sides by -5 to isolate y. So -5 cancels, and you're left with -7/5 x minus 5. And now that your equation is solved for y, go ahead and first identify your slope, which is m. That would be -7/5. And then your y-intercept, which is b, or -5. Okay, now that we've learned how to interpret slope-intercept form, let's go ahead and learn how to graph using it. So we have an equation in slope-intercept form, y equals 5/3 x minus 2. The very first step you want to do is identify and plot your y-intercept. In this case, we can see here that it's -2. Go ahead and plot it on your graph. And now that you have your y-intercept plotted, you can go ahead and move on to step 2. Now from the y-intercept, you're going to count your slope to get to the second point. In this case, our slope is 5/3. So now recall that slope is rise over run. So your vertical change is going to be 5. Since your slope is positive, in this case, you're just going to go ahead and count up 5 units. Now that you've counted up your rise, go ahead and count your horizontal change or your run, which is 3 units. Now that you've counted your slope, go ahead and plot your point right there. And because linear equations only require a minimum of 2 points to be graphed, you can go ahead and draw your line. Of course, if you want to be more precise, you can go ahead and count from this point and count your slope again, 5/3, and plot another point, but 2 points will suffice. Let's look at another one. We have y equals -2/5 x plus 4. Let's go ahead and first plot our y-intercept. So our y-intercept is +4. And I'll go ahead and plot that on the y-axis. And now let's go ahead and look at our slope. We can see here that our slope is negative. Recall that slope is rise over run, but in the case of a negative slope, your rise is going to go down. However, your run will still be the same. So go ahead and go down 2 units and then run 5 units to the right and then plot your point. You can see here that you graphed it correctly because your line is going to go up to the left, which represents a negative slope. Now you can go ahead and draw your line through the points by connecting them with a line, and that's how your graph will look. Another example, we have 2y minus 6x equals -8. They're asking us to graph using the y-intercept and slope, which means slope-intercept form, or y equals mx plus b. However, we can see that our equation is not solved for y yet, so go ahead and use inverse operations. So first, add 6x to both sides. And then you can go ahead and divide both sides by 2. That will give you y. And then I'll rearrange the right side to 3x minus 4. I'll go ahead and type that out so that it looks a little neater. And now that we have our equation set to y, we can go ahead and first start at the y-intercept, which as we identify here is -4. Plot it onto your coordinate plane on the y-axis. And once you have plotted -4, move on to step 2. Now from the y-intercept, we're going to go ahead and count the slope to the second point. We can see here that rather than a fraction, our slope is actually constant. The way you want to look at it is with a 1 underneath. So your rise will be 3 and your run will be 1. So always keep in mind that whenever you see a whole number, think of it as a fraction with 1. So go ahead and rise 3, since this is positive slope, and then run over 1, and then your point is right there. You can go ahead and connect your points like so, or if you'd like, you can rise 3 again, and then over 1. And you can also plot another point for more precision, but again, 2 will suffice. Okay, let's look at another one. We have 8x minus 3y equals 15. Again, we're still using slope-intercept form, so we're going to have to rearrange this to solve for y. So first, I'm going to do inverse operations and then do the addition of 8x. Subtract 8x from both sides, and I get negative 3y equals to negative 8x plus 15. Now I'll go ahead and divide both sides by negative 3. And I'll go ahead and rewrite this over here. I get y equals to negative 8 over negative 3 will just be positive 8/3 since the negative cancels. And then 15 divided by negative 3 would be negative 5. So this would be your equation set to y. Now that you have it in slope-intercept form, go ahead and identify your y-intercept, in this case, negative 5. Plot it on the y-axis. Then go ahead and look at your slope, which is positive 8/3. And now from your y-intercept, count 8 over 3 with rise over run. So 8 in your vertical change, rise 8 units, and then run 3 units for your horizontal change. Then go ahead and plot your other point, then connect the points, and there is your line. Okay, we're going to go ahead and graph y equals negative 3x plus 3 and identify the x-intercept. Now, same exact concept as the y-intercept. The x-intercept is where the line crosses the x-axis. So the x-axis is the horizontal axis for your reference. So let's go ahead and first graph it. We're going to use our graph to find the x-intercept. So we can see here that our graph is in slope-intercept form. So we can go ahead and graph it using a y-intercept and slope. So our y-intercept is positive 3. So I'll go ahead and plot 3 on our y-axis. Then we see here that our slope is actually negative 3. That would be negative 3 over 1. So we'll have a vertical change of down 3 units, and then run 1 unit to the right. And then once you've done that, you can go ahead and connect your points. And now you can analyze where your graph or your line crosses the y-axis. We can see here that the line actually crosses the y-axis right exactly at the point 1, 0. So now that we've identified the x-intercept, we can just go ahead and say that the graph y equals negative 3x plus 3 crosses the x-axis at the x-intercept 1, 0. So you're essentially just going to graph using slope-intercept form and then keep graphing until you create a line and you can clearly identify where the x-intercept is. Same exact thing, just different equation. We're going to graph y equals x minus 4 and identify the x-intercept. Now, when you just see x as your slope, you're going to visualize a 1 over 1 in front of it, or just a 1. So your slope will be rise 1 unit and run 1 unit. So now that we see that it's in slope-intercept form, let's first plot our y-intercept, which is negative 4. Once you've done that, we can see that your slope is positive. So rise 1 unit first, then run 1 unit. Since this is a pretty small slope, I'm going to do multiple points like this. And you can keep going for however long you'd like. I'll just go ahead and do those 6 points. And then you can go ahead and connect them with a line. Now that we've done so, we can go ahead and identify our x-intercept, which is right exactly at 4. Now, whenever they're asking you to identify the x-intercept, what I recommend is that you keep counting your slope from your y-intercept until you hit the x-intercept. So more than 2 points might be better for questions like this so that you can accurately determine what your x-intercept is. In this case, it's 4, 0. Okay, that's the end of today's lesson. You can find all additional information, including additional practice problems, lesson requests, and tutoring inquiries in the description box. Thank you so much for watching, and I hope to see you on the next lesson.